Today we're going to look at lesson 4.6, Arithmetic Sequences. If you look at the essential question, it says, how can you use an arithmetic sequence to describe a pattern? Now, this is not the first time that we have described a pattern. If you think back to when we were deciding if functions were linear or nonlinear, we looked for a pattern across which set of coordinates? The y-coordinates is where we had to find a pattern. Was there a number that was added or subtracted to keep that those y-coordinates moving? Now, what is a sequence? It's an ordered list of numbers. So that's what we're going to be looking at in today's lesson. We're going to have list of numbers, and they are sequences. Now, each number in a sequence is called a term. So we're going to represent this with a sub n. Now, some of you've got to be careful. You've got to work on writing down subs, because on your test last week, when you had the point slope formula and you had y minus y sub 1 equals m times x minus x sub 1, okay, your ones were big enough to look like you were multiplying the x and the y by 1. Some of you had written them so high that it looked like you had raised the x and the y to the power of 1. Okay, so a sub has to be small and it has to be down to the right of the letter A. But that little n represents the position of the number. You say, what do you mean the position? Well, look at the example I gave you in your notes. The list is 5, 10, 15, 20, and 25. 5 is sitting in the first position. It's the first term in your list. The number 15 is the third number in the list. So it's sitting in the third position. So when we talk about the n representing a position, that's what we're talking about. Which number in the list are you looking for? Okay, so I want you to highlight the word position. Now, what makes it an arithmetic sequence? Because we have a list of numbers, that's a sequence. But what makes it arithmetic? Just because we have a list doesn't mean it's arithmetic. Here's how you know. It says the difference, we call it the common difference. So I want you to highlight where it says common difference, because that's what you're going to hear me say over and over, all right? The difference between each pair of consecutive terms is the same. Now let's talk about consecutive. If we win 3 consecutive state titles, what does consecutive mean? Back to back, in a row, all right? So we're talking about, is there a common difference that when we add it or subtract it, it continues to take us to the next number, all right? The difference or the common difference between each pair of consecutive terms is the same. Now, let's put this into practice. The directions say, write the next 3 terms of the arithmetic sequence. So these directions are telling us this is an arithmetic sequence. But I'm going to prepare you for a test or a quiz question that says, determine if the sequence is arithmetic. All right? So here's what we have to do. We have to find the common difference before we can do anything. So how do we do that? It says we take the second term minus the first term. Now, obviously, you need to highlight that because it's important. If you don't know how to find the common difference, you're not going to be able to do these problems. So the common difference, you take the second term minus the first term. Now, look at letter A. What is the second term in this list? 0. So right here to the side, we're going to put 0 minus. Now, what is the first term? Negative 12. Now, be very careful, okay? Make sure you write down negative 12. That minus is from the formula. Second term minus the first term. So 0 minus a negative 12. What do you see right off the bat that we need to fix? Double negatives. So that means that 0 plus 12 equals what? 12. So the common difference is 12. So let's check and see if this is actually an arithmetic sequence. Does adding 12 continue to get us the next number all the way across our list? So here's what we're going to do. Negative 12, we're going to draw a little arrow, and we're going to put a plus 12 underneath it. Everybody, what's negative 12 plus 12?
12.
0. All right, 0. So what is 0 plus 12? 12. All right, it's still working. What's 12 plus 12? 24. So this is, in fact, an arithmetic sequence because adding 12 keeps moving us to the next number. Now, they've asked us to find the next 3 terms. So we're going to do this little arrow one more time, and we're going to add 12. What is 12 plus 24?
36.
Okay. 36 plus 12. 48. And what's 48 plus 12? 60. So there are the next three numbers in the sequence. Letter B, how do we find the common difference? What is the second term in this problem? 3 3/4, and we're supposed to subtract it from what? So 3 3/4 minus 4. Now again, we're trying to do some fraction work without a calculator. So think pizzas. You got 4 whole pizzas and 3 3/4 of them are going away. How much pizza is left? There's a fourth left, but is it a positive 1/4 or a negative 1/4? Negative. Very good, because 4 is larger. So we keep the sign of the larger number. Now, let's see if it works. Remember, we're testing. Is this actually an arithmetic sequence? If it is, negative 1/4 or minusing 1/4 will bring us to the next number all the way across. So what is 4 minus a fourth? Class? Again, you got 4 whole pizzas, and I'm going to eat a fourth of one of them. So I'm going to have 3 whole pizzas left, and then I'm going to have 3/4 left. So 3 3/4. Okay? Do it again. 3 3/4 minus a fourth. How much does that give me? 3 1/2. Okay? 3 1/2 minus a fourth. What does that give me? 3 1/4. So this is an arithmetic sequence. Subtracting 1/4 works all the way across. So let's keep going because I want the next 3 numbers. What's 3 1/4 minus a fourth? 3. What's 3 minus a fourth? 2 3/4. And what's 2 3/4 minus a fourth? 2 1/2. So the next 3 numbers are 3, 2 3/4, and 2 1/2. Now that leads us into writing the equation of an arithmetic sequence. And I don't want anyone to panic, okay? Here's why. You have been writing the equation of lines for a long time now. All right? On your test last week, you wrote the equation of a line in slope-intercept form, which was what? Just as a quick review. Y equals mx plus b. And you wrote the equation of lines in point-slope form, which was? Okay, everybody knows it. Ready? Y minus Okay, very good. So this is just a new formula that you're going to have to learn. This is a new equation. So I want you to highlight a sub n equals a sub 1 plus n minus 1 times d. Now you'll notice 2 things I just said. First of all, don't forget the plus sign. If you forget the plus sign, it's going to throw the entire problem off. And that is the mistake that I saw made last year. They left the plus sign out of the formula, which threw everything off. You also heard me say n minus 1 times d. If you look at this formula, there's a parenthesis and the letter d with nothing in between them. What operation is that? Multiplication. So that's why when we read it, we're going to say times d. Now, let's break it down, okay? Because there's a lot of new little pieces in here that you've never seen before. A sub n is the term that you are looking for. So if I wanted you to find the 100th term in your list, I would have a sub 100 right there. So a sub n is just the term that you're looking for. But think about that. If a sub n, if I can plug any number I want in place of n, this next piece says a sub 1. Well, they've plugged a 1 there. So which term or which number are they looking for when they say a sub 1? The first one. It's the value of the first term. So let that be easy. What's the first number in your list? That is your a sub 1. We already talked about n represents the position of the number. And of course, d is the common difference. So again, you have how you find the common difference. Highlight it if you want to. But you've got it in 2 separate spots now in these notes. Second term minus the first term. Now, example number 2 says, write an equation for the nth term of the arithmetic sequence, then find a sub 25. And we'll come back to that in just a little bit. But I've written out for you 3 steps to writing this equation. And you'll notice I added an extra word. So add this word into your notes and then highlight the steps. Okay, we're big about highlighting the steps so that when we study, we can go find them. Okay, find and plug in a sub 1 and d. Now your notes just say plug in. but you got to find them before you can plug them in. So add the word find, and we're going to find and plug in a sub 1 and d. Then we're going to distribute, and the last thing we're going to do is we're going to simplify. Okay, so let's look at letter A. We need to find a sub 1, and we need to find d. So we're going to write down a sub 1 equals and d equals. Ms. Johnson, do I have to do this? Yes, because I need to know that you can identify the first term and the common difference. Now, what is, for our problem, what is a sub 1? 4. The first number in our list is a 4. So that is the value of a sub 1. The common difference. Logan, how are we going to find the common difference?
Subtracting the second term out of the first.
All right, give me the numbers that we're going to be subtracting.
5 minus 4.
5, which is the second term, minus 4, which is the first term, giving us a common difference of what? 1. Good. So D equals 1. Now, you guys are used to this by now. We're going to write the formula down. We're going to say it as we write it down until we've got it memorized. All right? Do your best, but say it with me as we write it down. A sub n equals a sub 1 plus n minus 1 times d. So we bring down a sub n equals, what are we plugging in place of a sub 1? 4 plus n minus 1 times, what are we plugging in place of d? 1. Now, notice I plugged my d in parentheses. Yes, you must do this. If you don't, there's a very good chance, especially if we ever plug in a negative common difference, that you're going to forget that this is multiplication. So get in the habit of always plugging d into the problem in parentheses. Now, essentially, here's what we're doing. We are solving this equation for a sub n. So if you go all the way back to solving equations, and the sentence, don't call me after midnight, what's the first thing we're supposed to do when we're solving an equation? So look at step number 2. You're supposed to distribute. The question is, what am I distributing? Anybody think they know what we are distributing in this problem? Miles.
Are you going to multiply n minus 1?
So what are we distributing? Give me the one number that we're distributing. We are distributing a 1. Very good. Now, I want you to highlight it or underline it, either one. And we're going to draw arrows. You say, Ms. Johnson, why are you making me do this? I know how to distribute. I get it. But when have we seen the number that we're distributing behind the parentheses? We don't see that. We haven't seen that this year. So I want to make sure if you get to your homework tonight or you go to study for a quiz or a test and you're looking and you're stuck, that you can go back to your notes and say, oh yeah, that's right. I distributed this. All right? Because I've had people tell me to distribute the 4. But what stops me from being able to distribute the 4? What's between the 4 and the parenthesis? A plus sign. So I can't distribute over a plus sign. All right? So any distributing that you're going to do in these problems is going to be done after the plus sign. All right? So we've got 1 times n and we've got 1 times negative 1. Now, order does not matter here. I can do 1 times negative 1 and then 1 times n if I want to. As long as I distribute the 1 to both of the terms in the parentheses, the order's not going to matter. So a sub n equals 4 plus. Jamie, what do you want to get or do? When you distribute the 1, what do you get? N minus 1. I love it. 1 times n is n. You can put the 1 in front or leave it off. It doesn't matter. And then 1 times negative 1 is negative 1. Now, think back to don't call me after midnight. After we distribute, what are we supposed to be doing? Combining like terms. I've used the word simplify here. It's the exact same thing. So if you want to write down next to the word simplify, combine like terms, go for it. Whatever's going to help you remember this best. But what are the only like terms in this problem that I can combine? 4 and negative 1. So I'm going to bring down a sub n equals, we're going to bring the n down first. We are still in the mindset y equals mx plus b. We still want the variable term first. So a sub n equals n, and then everyone, what's 4 minus 1?
3.
Positive 3. So here is the equation of this arithmetic sequence. So here's what that means. I can now find any term that I want. I can find the 100th term in this list. I can find the 16th term in this list. I can find the 2000th term in this list if I wanted to. But what have they asked us to find? Go back to the directions. It says, then find
25th.
A sub 25. So right underneath the equation that you just boxed in, let's put A sub 25. Now, this is the next part where everyone tries to get confused. Instead of an N, what number have they put in place of N? 25. So when we go into the equation, N plus 3, what number are we supposed to put in place of N? They put 25 in place of N and said A sub 25. So 25 is what we are plugging in. Now we do the math. What is 25 plus 3? 28. So the 25th term in this list would be 28. That means if I sat here and added 21 more times, I would end up at the number 28. Let's look at letter B. What are the first two things we have to find in order to write this equation? A sub 1 and your D, or your common difference. So what is A sub 1 for this problem? 1. The first term in the list is a 1, so A sub 1 equals 1. Now, how did you find the common difference of this one? Tell me exactly what you subtracted. 0, the second term, minus 1, the first term, gave you a common difference of -1. So your D equaled -1. Now, everyone together, let's say the formula. A sub n equals A sub 1 plus n minus 1 times D. So A sub n equals, what'd you plug in place of A sub 1? 1 plus n minus 1. And what did you plug in place of D? -1. Now, this is a key reason why we plug our D in parentheses. If you didn't, and you just plugged in -1, there's a good chance you would have read that as n minus 1 minus 1. And that would have thrown off the entire problem. So make sure you always plug your D in parentheses, because step number 2 tells us to do what? Distribute. And what are we supposed to be distributing this time? -1. So again, underline it, highlight it, make it stand out, and draw yourself the arrows, okay? At least for the notes. I'm not saying you have to do this on homework, quizzes, and tests, but we're doing it in our notes. All right? So, Jason, when you guys distributed the -1 after you brought down A sub n equals 1 plus, what did you get when you distributed the -1?
1, negative, and...
Okay? So he did -1 times -1, which gave him a positive 1. And then he did -1 times n, which gave him -n. That's fine. That order doesn't matter. You could have put the 1 in front of the n if you wanted to, but it's not necessary. So, Noah, what was the next thing you guys did? What is step number 3 to these problems?
Combine my like terms.
Simplify or combine our like terms. And what were our like terms?
1 and 1.
1 and 1. So, what was your final answer? Noah?
A sub n equals 2 minus n.
Okay, be careful. What's wrong with your answer? What did I say we were going to always bring down first?
Oh, A sub n equals n minus 2.
Be careful. Your n is not a positive n. You just said n.
Oh, A sub n equals n, negative n plus 2.
There we go. All right. We're bringing down the variable term first, but be careful. Every number, every variable has a sign, and the sign is directly in front of it. All right. That is a -n. So when we bring it down, it's A sub n equals -n plus 2. Once you had the equation, we were supposed to find A sub 25. So, again, we're careful. There's a negative sign in the equation, so I'm going to go ahead and bring that down. And what am I plugging in place of n? 25. Okay? By plugging it in, now I have a -25 because there was already a negative in the equation, and I bring down the plus 2. So what was the 25th term of this sequence? -23. So again, if I sat there and subtracted 21 more times, I would end up at -23. Let's just say I had asked you for the 20 8th term. What number would you have been plugging in place of n? 28. Okay, what if I had asked you to find the 99th term? What number would you have been plugging in place of n? 99. So whatever number they give you in place of n is the one you're plugging into the equation in place of n. Now, example 3 is our ever favorite word problem. Okay, keep in mind when you work word problems, they should look like the problems you've just been working on. Okay, so it says a carnival charges $2 for each game after you pay a $5 entry fee. Now, there are 2 pieces of information in this problem. We need to identify those 2 pieces of information because when we write an equation, we typically have 2 different variables and each variable represents something different. So what 2 pieces of information are we given or are we talking about in this word problem? A carnival charges $2 for each game after you pay a $5 entry fee. So what do you see up there? Money. $2 and $5. We're talking about money. So one of the variables is going to represent money. What is the other variable going to represent in our equation? A carnival charges $2 for each. There's that word each. Each what? Game. Each game. So there's another piece of information. We're talking about dollars and we're talking about games. Now, letter A says write a function. And I want you to underline or highlight that word function. And we're going to come back to it in just a minute. Okay? Remember, a function is an equation. So they want us to write an equation that represents the arithmetic sequence. What are the first 2 things we have to find if we're trying to write the equation of an arithmetic sequence? A sub 1 and D. We just did this in example number 2. So the question is, what is A sub 1? You say, well, Ms. Johnson, how am I going to figure that out? Okay, well, they don't have A sub n, they have A sub 1. So 1 game. When you have played 1 game, how much money have you paid? Look at the problem. A carnival charges $2 for each game after you pay a $5 entry fee. So if I walk up to the very first game to play it, how much money have I already forked out? $7. I paid $5 to get in, and I paid $2 for that first game. So what is A sub 1? $7. I paid $5 to get in and $2 to play the game. So when I walk up to that very first game, I've already paid $7 out of my pocket. So A sub 1 is 7. Now, each time I walk up to a game, how much do I pay? I pay 2. So my common difference is going to be 2. All right? So we have the 2 pieces of information. We're going to plug them into our formula. But once again, let's write down our formula as we say it. Okay? Ready? A sub n equals A sub 1 plus n minus 1 times d. So A sub n equals, what's A sub 1? 7 plus n minus 1 times 2. All right, again, we're plugging that common difference in parentheses. Now, what is step number 2? I have found and plugged in A sub 1 and d. What am I supposed to do next? Distribute. Victoria, what am I distributing in this problem? The 2. All right, so again, underline, draw arrows. Underline, draw arrows. So, Victoria, when you distribute the 2, what do you actually get? 2n minus, be careful, 2 times n is 2n. 2 times negative 1 is what? Negative 2. All right. Again, she could have done 2 times negative 1 first and then 2 times n. It doesn't matter. As long as the 2n is positive and the 2 is negative. All right, so A sub n, what is the very last thing we're supposed to do here? Combine those like terms. What are they? 7 and negative 2. So, Kennedy, what does that give us? A sub n equals? 2n plus 5. Now, do not box that in, though, because it says write a function. So we have the equation.
Pardon the interruption.
How do we put a problem into function form? There's only one thing we have to change. A sub n has to be changed to what?
Y.
Nope. function, listen to me, remember on your test last week, we had to write a linear function f. If we want this in function form, it has to start with what? F of technically f of x, okay, but Zach is right. There's not an x in this problem, there's an n. So f of n equals 2n plus 5. That is the answer that we're going to box in. Now, I would star it, I would highlight it, just make it stand out, because nothing about finding the equation changed for us. We just have to make sure our final answer is written as a function. Now, bring down the function. F of n equals 2n plus 5. And remember, we have two different variables here. We have n all by itself, and we have f of n. What does the n all by itself represent? Remember from the beginning, we said there was money involved in this problem, and there were games. The n alone represents which of those? The games. Because remember, you paid $2 for each game. See how that says 2 times n? So the n by itself represents the games. What does the f of n, which is also like a y, remember it can be replaced with the letter y. What does f of n represent? That's the money. So look at the problem. It says, how many games can you play when you take $29 to the carnival? Where is the 29 going in our equation? In place of f of n. So 29 equals 2n plus 5. And we are right back to chapter 1 where we had to solve an equation. So what do we do first to solve this equation? We subtract 5. We have 24 equals 2n. How do we solve for n? We divide both sides by 2. So n equals 12 what? Games. Remember, the n represented the games. And don't forget to label, because this is a word problem. And that is lesson 4.6.